everyone. I'm super excited to be here and especially seeing a lot of like-minded people. Just quickly, I'm going to talk about the C and S part of the WCS conference. I'm glad that Melanie gave you a lot of exercise because I'll give you an opportunity to sit and meditate on some of my graphs. So I am Sudeshna Pabi, and I'm at Electric Power Research Institute. And I'm going to talk about a little bit more about what makes clean energy clean. So a little bit update about the current news. I'm sure you all are keeping up to date about the climate change and the recent report that has come up. And IPCC recommends drastic actions from all angles to limit the warming by 1.5 degrees. And that was much, in the past it was actually 1 degree, it's now 1.5 degrees. And 2 degrees would be catastrophic. Now, taking a step back, personally I'm motivated by this because my PhD dissertation focused on changes in the Arctic Ocean. So I saw firsthand the changes that's happening from satellite data, as well as I went on Arctic icebreaker to waters that has never been navigable ever in the man-made history or during the lifetime of humans. So this is clearly not fake news. So this is happening. So I can tell you that is the motivation from my perspective. But what is very heartening is there is a lot of incentive and push from the local and the state governments to address this. There are ambitious legislations that have been passed, especially by California and a number of other local and state governments. So that's where the incentive lies, and that's where the opportunities are to address this from a perspective of clean energy, which is all renewable as well as energy efficiency and electrification. So I'm going to focus on the stories of buildings, because as you see in that pie, commercial and residential sectors emit about 28% of all emissions. So if we can reduce that pie, we are doing significant improvement in terms of emissions. And here you can see the stacking order of how clean energy should be addressed for the buildings. Even though it's not the most sexiest of all, but energy efficiency is one of the most important foundational strategies for buildings. Because without efficiency, everything is, all the clean energies will be leaking out, and we'll be producing, and nothing will be saved or in terms of emission. Next is electrification, because only if we electrify, then we get to assess the benefits of the renewable energy. So that's why that's the stacking order. And the table you see is for the test you'll have at the end. Or you can just take it as the blue one is the sizing of PVs without energy efficiency, the blue column. And on the rightmost column is PV sizing with energy efficiency. So you clearly see that it saves resources and cost. So how are we addressing this? We are addressing this by demonstrating and deploying advanced energy communities. And what are advanced energy communities? They are a congregation of communities which are zero net energy within the sites, or they can be multifamily, they can be single family. And there are demonstrations around the country that, like you see in the US map that we are doing to see what actually happens when you install this advanced technologies and integration schemas in the field, because we already model them and we test them, but we want to know what happens in terms of real people and real behavior. And then these are, again, connected in terms of IoTs and optimized in terms of either rates or greenhouse gas or in terms of cost. So this is currently being ongoing in my research group. So now these are the graphs I was talking about. to meditate upon. And you can see the blue lines are energy emissions related to buildings which have mixed fuel usage. So they have natural gas heatings and some appliances, whereas the red ones are completely electrified buildings. And what is interesting is the difference in emissions are significant in the winter months than in the summer months. And a lot of it has to do with the heat pump, water heaters, and heat pump related benefits in terms of heating as well. So you can see when the emissions are kicking in and when the difference are kicking in terms of these two kinds of clean energy at the end use level. So here you can see an alphabet soup about zero net energy communities. And why I call it zero net alphabet soup? Because there are lots of definitions of zero net energy communities with respect to how much energy is being offset within the site or at the source, within the and offset with renewables at the site or out of the site, or with whether it's electrified or whether it has natural gas. But come to think of it, it all boils down to what our goal is, whether it's GHG emissions or whether it's cost emissions or whether to reduce the energy savings or multiple of this. So off the top and right away we can see that the all electric communities have the lowest emissions from an emission point of view. And again, bringing out efficiency on the right side in the orange curves, you can see that efficiency has a lot of benefits in terms of energy efficiency, savings emissions goals. So that's again, that's why the stacking order in terms of why efficiency should be taken very seriously. I'm excited to say that we are actually starting a project where we'll start an online market for energy efficiency. And this is a California Energy Commission project. So now that we are electrifying and doing a lot of energy efficiency, we also see a lot of new challenges. Anyone is aware of what this kind of graph is? It's a famous curve. Correct. So this is the quacking dirt curve. So this is actually at a building level. We are all aware of duck curve at a system level. So now we are seeing this at the building level, and the peaks are coming up even earlier and at a time that the utilities have not conventionally expected. So how are the grids infrastructure will be able to address that? So that's one challenge that we are actually addressing right now. And on top of it, we want to know, what are the GHG emissions changes that's happening because of this rapidly changing grid and prosumer kind of relationship. So while we're talking of the duck, we actually have a dragon. This is from the EV charging that's happening in the offices and at homes as well. And I'm pretty sure one of the WCS member will slay this dragon. I'm confident and I'm hoping so. It's because this will also have consequences in terms of GHG and in terms of grid responsiveness. So there's, right now I talked to you about the advanced energy community. So we need to know in the field how these strategies are working out. And now some of the other cool strategies that are coming up are connected homes, which are homes connected with the IoTs, and that you can optimize using software that aggregates all the DERs, whether behind the meter or front of the meter, and optimizes them with respect to the GHG or with respect to grid or cost. So there's a lot of opportunity, and the field is changing very fast. So I'm really excited to be here and hope you're excited as well. Thank you.